Okay, let's start our third seminar. Okay, first problem. What we have? We have two consumers with unit demand. What that means? What means unit demand? Each consumer wants to buy only 1 unit of good. That's all. Two consumers with unit demand. What we know about their willingness to pay, and what we know about the good. The good can be either of high quality or low quality. Two types of this good. And we know something about maximum willingness to pay of our consumers for each type of the good. So here are consumers, first, second, high quality, low quality of the good. For first consumer, 2A1, A1. For second, 2A2, A2. Where A1 and A2 are constants, but we know them. And what also we know? That A1 is bigger than A2, greater than 0. These are known numbers. This is our information. Maximum willingness to pay is what we get if we buy this good. This goes to our utility. This information about consumers. What we know about sellers? Our seller has 1 unit of each variety. So 1 unit of high quality good, 1 unit of low quality good. 1 unit of each quality. And he composed quality dependent prices. Price for high quality good and price for low quality good. And we need to find maximum profit. Let's discuss intuition and then we will solve. What options our seller has? He can sell high quality good to the first consumer, low quality good to the second consumer, or vice versa. Or he can sell high quality good to the first consumer and will not sell low quality good to anyone. So the second consumer will get none. Or he can sell low quality good to the first consumer, high quality to no better. Low quality good to the second consumer, high quality to no better. High quality to the second consumer, low quality to no better. So we have 6 options, 6 variables. And some of these options are more intuitively better than other options. What our seller wants to do? How do you think? We know that A1 greater than A2. So, which type he wants to sell to what consumer? Who can answer? Please, guys.
Can you repeat the question, please?
What variant, how much to whom to sell is more intuitively, is better intuitively. To whom what to sell? How do you think? To get maximum profit.
To high one consumer, but he will not buy anything. I mean, he will buy at the low. How will the low buy? I mean, is there any information about if our firm knows who is the high one and who is the low one?
Now, high quality goods. These are types of goods of high quality or low quality. Here are our two consumers with their maximum willingness to pay for such types of the good.
We should choose the first consumer. We should choose the first consumer because his ability to pay is high. No.
Okay, first consumer. For first consumer, we will sell what type? High quality, yes. And for the second consumer, we will sell low quality. This is one option. We do it to good, yes. And one more option is to sell only high quality good to only the first consumer, and the second will get nothing. These are two variants what to do. They we now will prove that we can make such conclusion. We do not need to to solve all 6 options what to do for our seller. We can think a little bit and choose only 2 options to consider. Okay, but we have questions. We have questions in our task, and let's do. Point A. In point A, we need to show that we need to prove 2 things. First thing, if second consumer wants to buy high quality, then first consumer wants to buy high quality as well. High quality, then first consumer wants to buy high quality also as well. Let's prove it. We need to write down two things that will tell us that second consumer wants to buy high quality good. We need to write down 2 constraints. Who will tell me what how to name these constraints? It was in lecture. First constraint is for consumer. He wants to buy something. This is individual rationality constraint. Individual rationality constraint for the second consumer. I will write down one once. Individual rationality. When our consumer wants to buy anything, when it is more not profitable but beneficial to him. If he will buy high quality good, what he will get? He will get 2A2. This will be his utility. But he will pay for this good how much? The price of this good. And this net utility of our consumer should be greater or equal to 0. In such situation, he wants to buy high quality. Second constraint.
2A2 minus P.
2A2
minus what? Minus P?
Minus price of high quality good, PH. Price of high quality.
Like its utility must be more than his payoff.
This is his willingness to pay. This is his utility, but he paid the price for this good for 1 unit. So this will be his net utility. Okay. And the second constraint is incentives compatibility constraint. Guys, who don't see, why you can see anything? It's about your bad internet connection or what?
I don't know, but the quality of video right now is super low.
Super low.
Maybe you should приблизить computer.
Okay, let's try.
Could you please take your
it's
camera
very
a little bit higher?
Better, no?
Could you please place your camera a little bit higher because of light?
No,
No,
I can. Okay, I will try, but I don't know.
В общем, на русском эти лампы отсвечивают от доски и плохо видно.
Они все равно будут отсвечивать. Только вот так.
Окей.
That's why we record our class. You can rewatch it. Okay, let's move on. And we have incentives compatibility constraint. Let's write down. Incentives. What this means? Our consumer will want to buy high quality much more than low quality good. So net utility from buying of high quality good to A2 minus the price of this good should be greater or equal to the utility from buying low quality good. If you will buy low quality good, he will get A2 minus the price of low quality good. Minus the price of low quality good. So let's rewrite. Price of high quality should be 2A2 should be greater or equal to the price of high quality good, and A2 should be greater or equal to PH minus P low. So, and now this information is about second consumer, and now we should connect this information with the info about the first consumer. Where is the connection between first and second consumer? Here, we know how to compare their constants, A1 and A2. You see? So, what we can write down? We can write down that we know that A1 greater than A2. This is from the task. So, what we will have? And if A1 greater than A2, that means that 2A1 greater than 2A2. Simple. And we use information from individual rationality constraint that 2A2 greater or equal to price of high quality good. And that means that 2A1 minus price of high quality good greater than 0. This is about individual rationality for the first consumer. This is IR1. What we also know, one more time, A1 greater than A2. That means that and A2 greater or equal to PH minus P low. From that information, we can write that A1 greater than H minus below. And this is incentives compatibility for the first consumer. You see? So what conclusion we can make? We can say that when second consumer wants to buy high quality good, then first consumer wants to buy high quality good as well as the second consumer. We proved it. So let's write down the conclusion. C1 wants high quality. End of. One more thing that we can prove from the task. We can prove that if second consumer wants to buy low quality good, then the first consumer wants to buy either high or low quality good. If second consumer wants low quality, then first consumer wants high or low. Wants to buy something, but we don't know what wants to buy. Okay. We will do the same steps, but we will write down the condition for second consumer to buy low quality, not high quality. Then he will do it. So individual rationality for the second consumer and incentives compatibility for the second consumer for buying low quality good. He will want to buy this good. He will want to buy something.
A2 minus PL.
A2 minus price of low quality good should be non-negative.
Yep.
And this net utility from buying low quality good should be
more or equal to buying high quality. Like 2A2 minus
price of high quality. Okay, yes. This is the system. Then rewrite A2 greater or equal than price of low quality, and A2 should be less or equal to PH minus PL. Now you see the difference. Yes? Here, same signs, and here, opposite directions. So what conclusion we can make? We will use the same information from the task that A1 greater than A2. And what conclusion we can only make? We can make conclusion only about individual rationality constraint. Let's see. A1 greater than A2, then that means that and greater or equal to PL from the first row. That means that A1 minus PL greater than 0. And this is individual rationality for the first consumer. But we cannot make strong conclusion about incentives compatibility. Why? Because we have opposite less or equal, not greater than or equal. So A2 less or equal than P high minus P low. And we also know that A2 is less than A1. So we don't know how to compare these two things. We don't know what is bigger, A1 or the difference between prices. So we can have two options. Here greater or vice versa. From here, we make conclusion that our first consumer wants to buy high quality good or low quality good. We don't know. Because we don't know how to compare. If greater, then he will want to buy low quality. Yes. If A1 bigger than difference between price, he will want to buy high quality. But we don't know.
The sign.
This is our conclusion. We don't know the sign. We don't know how to compare these two things. So we will make two conclusions. First consumer will want to buy high quality good or low quality good. This is what we need to prove. Yes? This is our proof. So, and our seller will use this information to maximize his profit. So, what conclusion we can make? We will use first. We'll use first and say that seller can sell only high quality to the first consumer, or we will use second proof to say that we can sell high quality to the first consumer and low quality to the second consumer. So we will have two options. Let's write down them. There are only two cases to consider. There are only two cases to consider. Case B, to sell high quality to the first consumer and low quality to the second consumer. And C, to sell high quality to the first consumer and to the second consumer to sell nothing. This we can make conclusion from the second proof, conclusion B from the second proof, conclusion C from the first proof. Let's move on and consider these two cases. First case, B, to sell high to the first consumer and low to the second consumer. So we should write down 4 constraints: 2 incentives compatibility for first and second consumer and individual rationalities. Okay, let's write down for the first. Here we need first consumer to want to buy high quality good. Okay, let's write down IR for the first. We will get 2A1 minus price of the high quality should be greater or equal to 0. Incentives compatibility for the first. 2A1 minus price of high quality greater or equal to A1 minus price of low quality. For the second consumer, individual rationality. He needs to buy low quality. So A2 minus price of low quality should be greater or equal to 0. And incentives compatibility for the second should be A2 minus below greater or equal than 2A2 minus price of high quality. So different incentives for different consumers. And with such constraints, our seller maximizes his profit. Profit of our seller will be how much? He will sell 1 unit of high quality good and 1 unit of low quality good. So this will be 1 multiplied by price of high quality good plus 1 multiplied by price of low quality good. We have no costs for our seller. And this we should maximize by prices pH below, non-negative, and such that this all 4 constraints hold. And now we need to choose binding constraints. What constraints will be hold with equality and what with a strong inequality? How do you think? What 2 constraints we should use with equality? From which consumer we will get all surplus? From our first or from second consumer?
Can you repeat the question, please?
Minus P. Now, here pH. What 2 conditions we need to use with equality? With this sign. How do you think? How to solve? Okay. We don't know, then we should suppose something. We should suppose something and then check. Okay, let's suppose that, for example, individual rationality, I don't know, for the second and incentives compatibility for the first are binding. Suppose. Now, suppose that individual rationality for the first and the incentives compatibility for the second are binding. For the first and incentives compatibility for the second are binding. Let's check. What means binding? They equals with equality. So, from here, 2A1 equal to price of high quality, and for the second, A2 minus price of low quality equal to 2A2 minus price of high quality. From here, this is pH star, put into the second, and solve. Price of low star will be 2A1 minus A2. So these are our optimal prices. But we should check other constraints. For all constraints, put these 2 optimal prices into our last 2 constraints, to IC1 and IR2. And check. Individual incentives compatibility for the first, 2A1 minus pH minus 2A1 should be greater or equal than A1 minus price of low quality minus 2A1 plus A2. Let's check. 0 greater or equal to A2 minus A1. From here, A1 greater or equal than A2. We know that it's okay. Yes, false. Then put our prices into individual rationality for the second. A2 minus price of low quality minus 2A1 plus A2 should be greater or equal to 0. From here, 2A2 greater or equal than 2A1. From here, A2 greater or equal than A1. This is
Excuse me.
true. This is not true.
Excuse me. Teacher, to be honest, I don't understand anything
What
because I don't see anything.
I don't know what to do. How to help? I will send you a recording, and I will send you the solution to this class. Okay.
But it doesn't solve the problem.
Check your internet connection. So we see that this is not true.
But the problem is not only my internet connection.
What is the problem? What I need to fix right now?
Can you move the camera to the right?
I'm not sure. Better. Okay, let's move on. So this is not true. So our what we suppose was mistaken. Here is our mistake. So we need to choose two other constraints that will be binding and check. Let's check. Suppose I have 2 and I see 1 are binding. Vice versa. Yes? Binding that holds with equality. And let's write down IR2. So EL star should be equal to A2 and IC1 to A1 minus price of high quality should be equal to A1 minus price of low quality. And from here, price of high quality should be equal to A1 plus A2. A1 plus A2. These are two classes. Put them into other two constraints and check. Individual rationality for the first. 2A1 minus BH star minus A1 minus A2 should be greater or equal to 0. Check. A1 greater or equal than A2. This is okay. Yes, that's true. I see 2. A2 minus BL star greater or equal than 2A2 minus BH star. A2 minus A2 greater or equal than 2A2 minus A1 minus A2. here 0, here A1 greater or equal than A2. This is true. Okay. So all conditions hold. That's why we can make the conclusion that these are our two optimal prices. Two optimal prices. That's why our maximum profit should be equal to the sum of two prices. And this is A1 plus A2 plus A2. This is A1 plus 2A2. This is our first option. First option for the seller to get such maximum profit. What we can also do. Point C. We can sell high quality good to the first consumer and nothing to the second consumer. From the point B, what we can say, that second consumer will get zero net utility. Yes, all consumer surplus will be taken by the seller from the second consumer. And from the first consumer, not all consumer surplus, not all net utility will be taken. Yes? Price is not too high, not to A1, but only A1 plus A2. In point C, if we want to sell only high quality good, then we need only price for high quality good. Set only PH. And for the first consumer, for him, that he wants to buy this good. This comes from individual rationality. We do not need to compare two types of goods right now, low quality and high quality, because we don't sell low quality type. Individual rationality. 2A1 minus price of high quality should be greater or equal to 0. So for our profit, that will be equal only the price of high quality for maximum, and price of high quality should be less or equal than 2A1. We see that optimal price will be the consumer surplus, this utility, willingness to pay of the first consumer, 2A1. So the profit in point C will be 2A1. And let's check that our second consumer does not want to buy anything. Let's check. Check individual rationality for the second consumer for such optimal price for high quality good. 2A2 minus this price minus 2A1. We see this is 2A2 minus A1, and this is less than 0. Yes, it's less than 0, so definitely our second consumer does not want to buy anything. Because buying high quality good gives him net utility less than 0. Okay, so now in point D, let's write here. In point D, we need to answer the question for what values of A1, A2 our seller will want to buy, will want to sell both types of goods. Let's write down this question. So that both goods will be sold. What we need to compare to answer this question? Guys, please. What we need to compare to answer this question?
Maybe the difference between ability to pay of first consumer and second. No?
The utilities will be more than prices. Yeah.
Who sells goods? Seller, yes?
Mm-hmm.
How he
The price must be less than utilities.
no. Seller is the firm. What firm compares when decides what to do? To sell both goods or only high quality good. Two options. So we need to compare profit in point B and in point C. Profit of our seller. Profit for both goods to be sold. Profit in point B. How to compare with profit in point C? What should be greater?
Point B.
Sure. Where we sell both goods should be greater or equal than profit in point C. So let's compare. A1 plus 2A2 should be greater or equal than how much? 2A1. So from here, 2A2 should be greater or equal than A1. This is our condition for selling both goods, not only one good.
And it will never happen.
Questions?
I mean, that's not true, and it will never happen. Like, we know that A1 is more than A2.
Yes, we know that A1 is greater than A2, but 2A2, we don't know how to compare with A1. This can be as option. You see? 2A2.
Mm-hmm.
Okay. So this is the end of the first task. It was the hardest task. If you have any questions, please ask right now, or we will move on, because we don't have a lot of time. Not much time. Guys, please. Okay. Second problem is simpler. We will speak about bundles. Ты тоже можешь спрашивать, если что. Конечно. Okay. Second problem. We also have two consumers, first and second, and three goods, A, B, C. Three goods, A, B, C. And for each good, we have information about maximum willingness to pay of each consumer. And here we have numbers, not constants. 8, 5, 2, 1, 3, 3. What else we know? Each consumer wants at most 1 unit of each good. Each consumer wants at most 1 unit of each good. So we cannot sell two goods A to the first consumer. We cannot do it. We can sell only one A, one B, one C to the first consumer, and for the second, the same. What we know about seller? Our seller has unlimited amount of each type. Unlimited amount. And we should find maximum profit. What we should do? We should consider different options. To sell these goods separately or to put them into bundles. What means bundle? Bundle по-русски корзинка. Набор. If we sell bundle, there will be price for this bundle. So let's consider all options, what we can do, write down profits, and then choose maximum profit. Let's begin. So point A. First option, to sell all these goods separately. To sell A, B, C separately. So we should set different prices for different goods. For good A, what options we have? What price we will set? Price of good A can be, for example, can be a maximum willingness to pay of the second consumer, can be 1. If the price will be 1, both consumers will buy for such price this good, yes? Both consumers will buy. That's why our profit from selling good A will be 1 plus 1 will be 2. Or we can set price as maximum willingness to pay of the first consumer, 8, such that only first consumer will buy this good. And that's why we will have profit, how much? Only 8. So, and we choose. We see that 8 greater than 2, so we choose to have profit 8. So this will be our optimal price. Let's write down the same about good B. What options? To set price 3, such that both will buy, the profit will be 6. Or to set price 5, such that only first will buy, the price, not price, but profit will be 5. It's 6 greater than 5, so we choose 6. And this is optimal price. For good C, price can be 2 or 3. If 2, then both buy. Then profit 6. And if 2, yes.
Excuse me, I guess there is a mistake. You wrote that at the price for the good B at 3, the profit will be 6, but it's 8, I guess. 5 plus 3?
No, we just take the minimum 3.
We set price 3, and 2 consumers will buy for this price. 2
Mhm.
units will be
Ah,
bought
okay,
for
okay.
free. Okay? And if we will set the price 5, only first consumer can buy for such price. So the profit will be 5.
Sorry, why you change 3 to 2?
Because if we will set the price 2, so both consumers will buy for such price. And the profit will be 4. 2 multiplied by 2, 2 units. And if we will set the price 3, only second consumer will buy, and our profit will be 3. Yes? Higher profit 4, and this is our optimal price. So, maximum profit in this point will be 8 plus 6 plus 4. 18. But this was only first option, to sell all goods separately. Then there will be 3 options how to bundle. No, 4 options. Point B. We can sell good A separately and goods B, C as a bundle. So if we sell the good A separately, we know everything about this situation. So for A, price will be 8 and profit will be 8. But for bundle BC, what information we need? We need maximum willingness to pay for such bundle. So let's sum up. For consumer, for the first consumer, maximum willingness to pay for such bundle, how much?
7.
7. 5 plus 2, 7. And for the second consumer, 3 plus 3, 6. So here are our options, what prices to set. If we will set price for such bundle, for bundle BC as 6, both consumers will buy for such price, both. So our profit from selling such bundles, we will sell 2 bundles for price 6, and this will be 12. If we will set price for such bundle 7, only first consumer will buy, and our profit from selling such bundle will be 1 multiplied by 7. So we choose higher profit. This will be our optimal price. So maximum profit in this was point A. In point B, how much? 8 plus 12. 20. This will be profit if we sell A separately and BC as bundle. Next, C. We will sell B separately and AC as bundle. About B, we know everything. Optimal price for B is 3, and profit from selling B separately is 6. Okay. What about bundle? AC. First consumer. His maximum willingness to pay 8 plus 2, 10. Yes. And for the second consumer, 4. 1 plus 3. Then prices. Price for AC can be 4, such that both will buy. That's why profit from BC will be 8. if price of AC, if price of AC will be 10, then only first consumer will buy, such that profit from selling one bundle of AC will be 10. We choose higher profit. This will be our optimal price. So profit in point C, when we sell B separately and AC as a bundle, will be 6 plus 10, 16. Next, D. In point D, we sell C separately and AB as bundle. Same steps. We see price 2 and profit from selling C separately 4. For AB, consumer first consumer maximum willingness to pay for AB 8 plus 5, 13. And for the second, 1 plus 3, 4. So 2 options. If price will be 4, then both will buy. Then profit from selling AB as a bundle will be, we will sell 2 bundles for price 4. Profit will be 8. If we will set price 13, then only first consumer will buy. So profit from selling AB will be 13. Yes. This is our best option. And profit in this case, in point D, will be 4 plus 13, 17. E. We have option to sell a big bundle. All these goods in one bundle. So sell A, B, C as a bundle. Let's sum up maximum willingness to pay. How much each consumer will be willing to pay for such bundle? First consumer, 15, yes, 8 plus 5 plus 2, 15. And second consumer, 7. 1 plus 3 plus 3 is 7. So 2 options. Price of A, B, C can be 7, such that both consumers will buy. So profit from selling A, B, C as a bundle will be 2 multiplied by 7, because 2 bundles we will sell, 14. Or price of A, B, C can be 15, such that only first consumer will buy, but will have higher profit. 1 multiplied by 15. Higher profit. So this will be our profit in point E. So, and now let's consider all our profits and choose the best profit. What options we have? In point A, our profit 18. In point B, our profit 20. In point C, I will this profit from A, this profit from B, profit from C, 16, profit from D, 17, profit from E, 15. What is the best option for us? Maximum profit will be from 20. So it's better for us to sell A separately and BC as bundle, because it will give us a maximum profit. Why is it so? Let's write down the conclusion. Better to sell A separately and BC as bundle. And maximum profit will be 20. If we look at our maximum willingness to pay for our consumers, consumer, per second, A, B, C, once again, we will see why is it so. 8, 5, 2, 1, 3, 3. Let's look at BC. You see that first consumer, if we compare B and C, first consumer wants more good B, his maximum willingness to pay higher than for the second consumer. And for good C, it's vice versa. You see, second consumer wants C more than first consumer. So these maximum willingness to pay, they are negatively correlated to each other. And that's why it is better to sell these two goods as bundle. It's like a business lunch in our university. I want soup, you want, I want only soup, you want only a second dish, but we will eat the same bundle, business lunch, and we will pay more. Okay, and if we look at good A, we see that first consumer's willingness to pay is much higher than for the second consumer. That's why we sell only to the first consumer this good. Let's write down these conclusions. First conclusion. Good B and C, they are negatively correlated. Across consumers. But still not too much. And second conclusion, in contrast, A is preferred by first consumer much more than by second consumer. In contrast, A is preferred by first consumer much more than by second consumer. If they are not so negatively correlated, not too much, then we will sell bundle of this. If very different willingness to pay, then we will sell to one consumer only this good. So this is the end of our second task. You can ask questions, please. But it was much simpler than our first task. Yes. And you should consider all cases, and then choose maximum profit, best option. So please ask questions. If you don't have questions, we'll move on and solve the third problem.
The last two ideas is just explanation for us. I mean,
this is the intuition why the option to sell good A separately and BC as a bundle is profit maximizing option.
but when I don't write this, if I don't write this, it's not a mistake, yes?
If you have question explain, then you should write this. If you don't have in your question, in your task, if you don't have word explain, then you don't need to write this. Okay. So the third problem. In the third problem, we will speak about two-part tariff once again, as in the previous class. We have monopoly with total costs C q squared divided by 2 greater than 0. What else? We have two consumers with different demands. First consumer has demand 1 minus P. Second consumer has a greater demand, bigger, K multiplied by 1 minus P, where K greater or equal to 1. You see. So, and our task is to find best two-part tariff in two situations. First situation, when both consumers are served, when we sell to both consumers, and the second option, when we sell to one consumer. So, what we know about two-part tariff from the previous class. In two-part tariff, we have entry fee that should be paid by each consumer who wants to buy, plus we have per unit price for each unit of good that we bought. Per unit price. So, what we let's draw a graph, draw a sketch for these two demands. Quantity here. If price is equal to 0, the quantity demanded of the first will be 1, quantity demanded of the second will be K. So here 1, here K. If quantity demanded is equal to 0, then price is equal to 1 in each situation. So this is the demand for the first consumer, D1. This is the demand for the second consumer, D2. If we will set per unit price, for example, here, how much will be bought by each consumer? First consumer will buy how much? 1 minus P. And second consumer for such price will buy K multiplied by 1 minus P. So we can count consumer surpluses as the area of triangle. This is consumer surplus for the first consumer, easy. Will be 1 minus P squared divided by 2. For the second consumer, will be how much? K multiplied by 1 minus P squared divided by 2. Blue area. So, why we counted it? We counted it because we have two-part tariff and we have entry fee, and we have two options. To set entry fee as the consumer surplus of the first consumer, red one. In such situation, if our entry fee will be not so big, how many consumers will buy from us? 1 or 2? Both or only one consumer? If entry fee is equal to consumer surplus of the first buyer.
Both.
One.
Both, yes. And the second option, to set very high entry fee that will be equal to the consumer surplus of the second consumer. In such situation, only this second consumer, as he wants more to buy this good, will pay entry fee and will buy from us. So we should consider these two options. And then compare profits. So first option, point A, when both buyers are served, both consumers are served. If both consumers are served, then we set entry fee equal to consumer surplus of the first. Yes, 1 minus p squared divided by 2. Then we have both consumers, so we will have market demand. Total sales will be equal to the demand of the first plus the demand of the second. Let's sum up. This will be 1 plus k multiplied by 1 minus p, 1 minus price. Inverse demand, to write down profit, inverse demand is how much? 1 minus 4 divided by 1 plus k. This put into profit. Profit in such situation will be revenue. Let's write down entry fee, 2 entry fees, because both consumers will enter our market. 2 entry fees, 2 multiplied by this one. 1 minus, but instead of price, we write down the inverse demand function. 1 minus 4 divided by 1 plus k squared divided by 2. This is 2t plus total revenue, inverse demand, price multiplied by quantity. 1 minus 4, 1 plus k multiplied by quantity minus total cost. Total cost sigma squared divided by 2. This we maximize by quantity greater or equal to 0, and we will do our steps as always. First order condition, second order condition, then write down quantity, optimal quantity, put it into inverse demand, optimal price, and then optimal entry fee, optimal tariff, and profit in such situation, profit in point A. I will write down for you profit in point A. This will be 1 plus k squared divided by 2 multiplied by c, 1 plus k squared plus 2k. So you can find it by yourself. Let's move on. Point B. Point B, when only one consumer is served, only one served. I want to write down only the difference between these 2 points. Only one served. Then, what we will set? Our entry fee will be how much? It will be the consumer surplus of the second consumer. Why? Because he wants more. And only this consumer will enter the market, will pay such big entry fee. This will be k, 1 minus p squared divided by 2. So, total sales, we will sell our product only to this consumer. So total sales would be only sales to the second consumer, it will be K1 minus P. The inverse demand will be 1 minus Q divided by K. And profit will be, we will sell only to the second consumer, so we will have only one entry fee, K1 minus inverse demand, 1 minus Q divided by K, square divided by 2. This is entry fee, plus total revenue, 1 minus Q divided by K multiplied by Q. This is total revenue, minus costs, CQ squared divided by 2. And this we should maximize by quantity greater or equal to 0. Same steps. First order condition, second order condition, maybe shut down if you want. We will find optimal quantity, optimal price, optimal entry fee, optimal tariff, and profit. The profit will be, in such situation, I will write down it to you. K divided by 2, 1 plus CK. And in point C, we should answer which consumer will be served when K, this parameter, is equal to 1 and K is equal to 2. In both such situations, we should compare profits, and we will say that both consumers should be served. But my task for you, C is not interesting task. You can answer like in your task. Please find for me K such that we will switch from selling to both consumers to sell only to one consumer. Switch. From selling for both to only one. You should compare these two profits. Here, B compare with B A, and you can do it in Wolfram.
K should be more than 2, no?
More than 2?
Yes.
Or maybe more than 3? I don't know. I didn't count. More than 2?
No, I just said that. It's just my assumption.
We should compare and understand what K will be. This for switching. Yes. Okay. So that's all. I will send you video recording for only your online group. I will send you a video recording because I understand that we have problems with internet connection, something like that. And I will send you my notes, solutions. Okay, but this will be at the end of the week, maybe on Friday. Okay.
Okay.
If you have questions, please ask. If no, so thank you, and see you the next week.
Goodbye.
Thank you.
Так. Все, я останавливаю запись.